Hi everyone, we're going to use the scale factor to change the measurements, the perimeters, the areas of a triangle. So given the scale factor as a rule right here, 2.7x, 2.7y, that means that our scale factor is just going to be 2.7 since we're multiplying both the x and y coordinates by 2.7. Now, if the side lengths are being multiplied by 2.7, since that's our scale factor, the perimeter is also just multiplied by the scale factor. So we say the new perimeter is just the old or the original perimeter times the scale factor. So if the old perimeter was 46, then the new perimeter would just be the old perimeter, 46 times 2.7. And it says that the rule from ABC to DEF, so 46 to the new one is 2.7. So we are doing this in the correct order. So 46 times 2.7 would be our new perimeter, which is 124.2. And the reason this works is, think of an easy example. Say we got a rectangle that's 1 by 3. Well, the perimeter of that would be 4. Nope, just kidding. It's 8. I want to see you're paying attention there. You got to make sure you add up all the sides. That's got to be 8, right? So then for the new, if I were to multiply this by a scale factor of, let's say, 3. Say I want to do times 3, make a new rectangle. So that would be a 3 by 9. And then we find that perimeter. Well, we would add up all the sides, 3, 9, 3, 9. So that would be 12 and 12, which is 24, the new perimeter. So if it was 8 and now it's 24, that's just times 3, and that was our scale factor. So that just shows another example of why this works. Just take your scale factor, multiply the sides, and then adding up all those new sides, that means that your new perimeter is going to be the scale factor times as big because all the sides are multiplied by that scale factor. For the next one here, it looks kind of tricky because it's like, ooh, angles. Maybe I should multiply that. But actually, no, don't do that. Because if two triangles are similar, say take this triangle and then a different version of it. Oops, let's try again. I take this triangle and I make it a little bit bigger or smaller. The angles are actually never going to change. If this was 100 here, this would also be 100 degrees. And that should make sense because every triangle has a sum of 180 degrees total. So how could it be bigger if it's just a bigger triangle? Well, it can't. In both of them, the angles must add to 180, so they can't be 3 times or 4 times as big. They've got to still add to the same total. So if A corresponds with D and angle A is 100 degrees, then the measure of angle D is also 100 degrees. They're just equal. We don't use a scale factor at all when it comes to angles. For this one here, we're given the scale factor as a percent. It'll be easier to make that into a decimal. That would be 470 out of 100, which is 4.7, if you just divide those two. And then if we take A, 9, negative 8, and apply that scale factor times 4.7, we get the corresponding coordinates here of D. So all we have to do is just take 9 times 4.7, and we get 42.3. And then we do negative 8 times 4.7. And we get negative 37.6. And that would be the new coordinates of D, just using that scale factor from ABC to DEF.